"60 years ago at NASA's Glenn Research Center, engineers were hard at work building components for the Apollo missions to land a man on the moon. Since second grade, I have loved both science and science fiction stories, from watching Dexter's Laboratory on TV to reading Isaac Asimov books. I just knew I wanted to be a scientist someday. After learning about the Apollo missions in school, I realized that not only did I love science, but I also loved the history and the stories of the people behind those groundbreaking innovations. It's through these stories, both historic and science fiction, that we truly engage with and learn the lessons science teaches us. One such lesson comes from Soviet astronomer Nikolai Kardashev, who endeavored to teach us the importance of energy. In 1964, he proposed a method of measuring a civilization's level of technological advancement based upon the amount of energy they are capable of harnessing and using. A Type 1 civilization can access all the energy on its planet and store it for consumption. A Type 2 civilization can directly consume a star's energy. A Type 3 civilization can capture all the energy emitted by its galaxy. For reference, humans on Earth are a Type 0.7 civilization. This became known as the Kardashev scale and became the standard which all modern science fiction authors used to conceive the amazing technological advancements of their story's future. From this lesson, one thing was very clear to me. Energy is the key to the future, just as Gabriel discussed the importance of energy to advance electrical propulsion for spacecraft. This common thread of energy was prevalent throughout my favorite movies and comic books when I was young. I loved watching Star Wars and feeling that sense of wonder as we met new alien races in the now famous Cantina scene. I was riveted, watching as they traversed the galaxy to battle the Galactic Empire, which, by the way, was a Type 2.5 civilization. I was transfixed, watching the clash of lightsabers as they effortlessly swatted away blaster attacks. And of course, who can forget the coolest thing about Star Wars? The Force. An energy so powerful, Darth Vader once declared, "The ability to destroy a planet is insignificant next to the power of the Force." I love watching science fiction movies. The reason I love watching science fiction movies is because they activate the imagination. They ask, imagine a future where anything is possible. What would that look like to you? Working at NASA, we ask this question daily and try to answer it with our research. In 2019, we were asked to imagine a future where large drones could bypass traffic and transport 6 passengers 120 miles in less than 30 minutes. These large drones are referred to as electric vertical takeoff and landing, or eVTOL vehicles. They are already in the flight testing stage by commercial companies, and NASA is helping with the research and design criteria. I wondered what energy storage systems we would need to improve these eVTOL vehicles, because they're currently using lithium-ion batteries. Developed in 1970, lithium-ion batteries function using something called intercalation chemistry. Upon discharge, lithium ions will flow from the graphite anode to the metal oxide cathode through a porous separator imbibed with an organic liquid electrolyte. Lithium-ion batteries have been an amazing innovation, receiving the Nobel Prize in 2019, but they were never intended for aerospace vehicles. Unfortunately, we're reaching the upper limit of their performance. This means an eVTOL vehicle won't have enough energy to travel far. Plus, the organic liquid electrolyte required for lithium-ion batteries to function can catch fire. You may have heard about this happening in electric cars, laptops, and smartphones. Needless to say, for a flying car, this would be really bad. We knew we had to develop both a new battery architecture and a new battery chemistry, so we started with a cool acronym. As a tribute to the lightsabers in Star Wars that were powered by the diadium battery, we called our battery the Sabers Project. This stands for Solid-State Architecture Batteries for Enhanced Rechargeability and Safety. Einstein reportedly said that his best ideas came to him in bed, in the bath, and on the bus. In the case of the Sabers Project, our team's best ideas came to us while eating burritos at Chipotle in North Olmsted. We knew we had to develop both a new battery chemistry and a new battery architecture in order to achieve our goals of increased energy and safety. For the chemistry, we settled on a high-energy conversion chemical reaction with sulfur as our fuel. Sulfur is abundant and energy-dense. In fact, the US is the second largest producer of sulfur in the world, which contributes to its low cost of only 1 cent per pound. For the architecture, we settled on using a solid-state battery, which is built like a deck of cards, with each card being one of 4 layers: the anode, the electrolyte, the cathode, and the bipolar membrane. Using this design, Sabers batteries contain no flammable liquids. Instead of wiring tabs on every layer, we stack the layers together directly, called a bipolar stack. That slashes weight and lets the voltage climb naturally, layer by layer. Inside each layer, lightweight sulfur stores energy, while a ceramic electrolyte shuttles lithium ions safely. The result is more than 500 watt-hours per kilogram. That's about twice the energy of your cell phone and today's electric cars. Put differently, the same size battery will carry an eVTOL vehicle twice as far. And safety isn't a footnote, it's a headline. Because Sabers uses a non-flammable solid electrolyte, you can puncture, bend, or cut the battery, and it won't catch fire. After years of development, I am proud to report that on January 14th, 2025, a NASA test satellite rode aboard a SpaceX Falcon 9 rocket and was deployed into space. Currently, it's circling Earth, and we're monitoring the voltage of the Sabers batteries on board. Soon, we'll test our latest Sabers battery pack. It'll be wired into a NASA test satellite on board Firefly's Elytra Mission 1 spacecraft. Once deployed, it'll be in space for a longer time to acquire more test data. Our research is going well, but we still have some areas of improvement. We need to increase how long they last and how to produce them in mass before Sabers can replace lithium-ion batteries. From the start of this project, we've been a collaborative and multi-center family. NASA Glenn is the power and communications lead for Sabers testing and development. NASA Langley leads our materials development and battery pack design. And before fabrication, NASA Ames creates computational models that saves time, cost, and effort, overall improving efficiency. Keeping with the theme of energy, youthful energy is important. 49 interns have come through NASA's labs and learned about solid-state batteries and cutting-edge battery technologies. With NASA researchers working alongside interns, we've produced 21 new technology reports and 5 patents that covers all the components within the battery. So far, we have 3 Sabers licensees. So, the team and I are very proud and excited that our research is having a tangible impact on both industry and society at large. So, we have successfully produced a solid-state lithium-sulfur battery that's both safe and high energy. And It's made from low-cost and abundant materials sourced right here in the United States. This research anchors a domestic supply chain that both strengthens U.S. industry and national security. I think we're living in an amazing time in history. We stand at the precipice of the AI revolution with robots to help us, and we are finally realizing the dream of flying cars to reshape the way we travel, making roads and those dastardly construction delays a thing of the past. For all these innovations, there's one thing we know for certain. Energy is the key to the future because everything relies on energy. Like advanced communication systems you'll hear about next from Sarah. I have always loved the quote from Sir Isaac Newton, who wrote, "If I have seen further, it is by standing on the shoulders of giants." To me, that means the progress we've made wouldn't have been possible without the pioneering work of previous NASA researchers. And so, as we move toward a Type 1 civilization and our own galactic civilization, just like in Star Wars, we can think back to the wise words of Darth Vader. I believe I misquoted him before, because if you watch the remastered version of Star Wars, what he actually says is, "The power of the Force is insignificant next to the power of the Sabers battery technology." Thank you.